Hello again, welcome to the next video. In this case we're going to predict the formation of precipitants. So in the previous video you learned how to use your solubility table to work out if something is soluble or insoluble. You got the theory behind what happens when we mix two ionic solutions, how you get a soup of positive and negative ions, and some of those positive and negative ions will join together and form the precipitant, and that's all predicted by using your solubility table. Let's put it into practice. How do we actually do it? So, how do we predict? Well, when two solutions are mixed, we need to check if one of the possible products is insoluble. Now, how do we know what the possible products are? Well, this is a way of working it out. So just recapping, we need to know our solubility table. And just a quick one off. If we're looking for a precipitant, where are we looking in this table for the precipitants? Well, it's in this section here, and it's in this section there. There are our precipitants, and that's what we're interested in. Let's move on. Let's do an example, and how do we work out what the possibles are? We've got two things. We've got lead nitrate solution is mixed with potassium iodide solution. Alright, now they're both ionic solutions. When we do ionics, this will become second nature to you, but trust me, they're ionic solutions. And there's our formulas, and they're in solution, so that tells us that we've got lead ions and we've got nitrate ions in solution, and AQ also tells us we've got potassium ions and we've got iodine ions in solution. So when we mix that together, we should have a soup with 4 ions, 2 negatives and 2 positive possibles floating around. And so one way of drawing that is you draw a box 4 ways, and you have your first solution there, which in this case is lead nitrate, and so you put your 2 ions, your positive ion and your negative ion, from that solution there. And then the second solution is potassium iodine, so you have a potassium ion and an iodine ion. So you've got your ions in separate boxes. Then you use the crossover technique, another crossover technique. Basically what you're looking at is, will this lead combine with this iodine to form an insoluble compound, and will this potassium and this nitrate form an insoluble compound? And so you need to go to your table of ions, go to the nitrates, and you will see that all the nitrates are soluble, and so that combination is not the precipitant. And then you go to your table of iodides, and you will see that lead iodide will be insoluble, or has a low solubility, in another way of saying it. And that's how we work it. And so check the 2 possibilities, which one will be insoluble, and we learn that it's the lead iodide that is insoluble. And so that then tells us what to write for the rest of the equation. Does that come up? Is that the same one? Yes. So here we go. So we now know that we get a precipitant. We didn't know that it's a yellow precipitant, but we know that it's lead iodide. And that's what it looks like, and you'll be doing this when we do our solubility prac, or our precipitation prac. And there it's settled. Some of it's floated to the top just because of some bubbles in the test tube. And so let's write it now, because that's the next important thing. You notice it's already been balanced, because I've stolen it from a textbook. So we wouldn't normally write that 2 there, because we don't know that it's balanced, but this is the correct formula. I hope we recognize for lead 2 nitrate. Remember the 2 tells us something. And so when we want to write the formulas for lead 2 iodide, we've got to make sure we write the correct formulas, and that would be the formula for lead 2 iodine. And so we're left over with potassium nitrate, and if we go back, way back here, potassium nitrate was the one that we found wasn't insoluble. And so those ions remain in solution, and the way we write that in this sort of equation is we put them as AQ. It's exactly the same as if we have a solution of potassium nitrate. And then they put the numbers to balance it. So quite complicated process, hey? And this is referred to as the full equation, in that it has everything that we need to know, the states, the formulas, and it's balanced. We can condense it down into what's called the ionic equation, and there's a trick to writing the ionic equation. The trick is once you work out what the precipitant is, okay, once we worked out that the precipitant was going to be lead to iodide, you then write the equation so that you have the ions that go to make that formula. And in this case you must have a lead ion, and because it's lead 2, it's got to be lead 2 plus, so you draw that ion, it's in solution, so it's AQ, and so that goes there. And then you have iodide. Now there's 2 iodides in the formula, so you need 2 iodides. You look up the charge and hopefully you know that it's -1, so you show the charge. Now in the ionic equation, it's basically writing the ionic equation for a precipitation reaction. You basically write the ions that make the precipitant, okay, but make sure it balances. And in this case it balances because you've got 2 iodides and 1 iodide. And also show charge. Now that confuses students, because here we're showing charge. Up here in the full equation you don't have any charge, because in the full equation we're using the full formulas. And as we learned earlier, when you have the correct formula for a compound, it has no charge, so there's no charge being shown. Down here we're just writing the ions that go to make the precipitant. Right, let's get rid of that. And what do we got here? Another one to do. Sodium carbonate and copper sulfate. So let's do it longhand version just to get you aware. Now what's the formula for sodium carbonate, I ask you? Okay, you do have to learn how to write this formula. Now you go sodium is Na plus, carbonate is CO3 minus 2, so we're going to have CO3, that's carbonate, and copper 2 sulfate is going to be CuSO4. Now I know that off the top of my head, but you'd have to use the table of ions and work out what the correct formula is. It takes you a little while, but the more you do, the faster you get at it. Now these are in solution, so we write AQ, and this is AQ. Alright, and we want to know whether or not a precipitant forms. I should have moved that a little bit to the left. And so what I do is I draw my little box. Okay, and we have the ions for the first solution, so that's going to be Na plus and CO3 minus 2. We've got the copper 2, so that's Cu2 plus, and we've got the sulfate SO4 minus 2. So there are our ions, and we want to check if these guys form a precipitant or these guys form a precipitant. So on our solubility table we look up sodium sulfate, and we would find that sodium sulfate is soluble, and we look up copper carbonate, and we should find that copper carbonate is insoluble off the top of my head. Let's just check that, make sure I'm not running you amok. Copper sulfate, I think I'm right somewhere here. Yes. Okay, and so that's how we use our solubility table to predict. So we would write that up. Now we've got to write the correct formula for copper to carbonate, and that would be CuCO3, because they're both minus, well they're both 2, and then we also get plus, I'll just write this down here in case my big ugly face gets in the way, Na, we need 2 of those, SO4, and don't forget the most important thing is we need an S there because that's the precipitant, and we've got to remember to write an AQ there to tell us that that's not soluble, and that goes there. And then the next thing is you've got to check your balancing. Now I think if I get rid of this writing, all that will appear before your very eyes. So there's our reactants. They use the solubility table, blah 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 blah. You can read that, pause it, read it. Why not? Won't hurt you. And then they write the balanced equation, and yes, I got it right. And they didn't have to actually add any prefixes or coefficients because it was already balanced, which is nice of it. So in class we've already done that question, and you'll have a go at doing this question in class, and I'll give you a whole sheet of other precipitation reactions to practice on. Alright, and let's get rid of that writing, and in the next video we'll look at acid-base reactions and neutralization reactions, which should be fun. Cheerio!